All right, let's solve this log equation. First of all, every log equation is like a puzzle, really, and you have to figure out from all the properties that I have, and I have those properties right here. Here are the log properties. You can get this cheat sheet from my website, 204tutor.com, and you can see all the log properties, and I'll refer back to these. And then logs, of course, are related to exponents, so here are all the exponent properties. And so we're going to refer back to these. And the more you have these properties readily memorized in your head, the easier it is to do all these problems, because each problem is kind of like a chess. It's like a puzzle almost. And you have to figure out, all right, what am I going to do to solve this equation? And you've got to track in your head, or what are the things that I know how to do. The first thing I'm going to do is I'm going to recognize that these are all base 4, and so I want to make each side log base 4 of something, which I already have on the right side, log base 4 of 2x. So if I could somehow condense this down to one log expression, then I can solve this problem more easily. And so that property is right here, and I'm going to go this direction with it. So here's what I have, and I'm going to turn it into this right there. So the argument of my logarithm when I'm subtracting is x plus 1 over x. That's the log property I have. Now I can see that I have the log base 4 of one thing equals the log base 4 of another thing. So I can just say that those things, the arguments, are equal to each other. That's called exponentiating each side, or I just call it the duh property. You can just say duh. Those two things have to be equal to each other. And so now I have this right here now is no longer a log equation, it's a quadratic equation. So now I'm going to solve this quadratic equation by multiplying both sides by x. And now the way you solve a quadratic equation is you set it equal to 0 and you use the zero product property. So I'm going to subtract x, and I'm subtracting 1. And now preferably I could factor this, and let's see if it factors. If it doesn't factor, I have to use the quadratic formula. So if this factors, it's going to be 2x and x, and then this is going to be plus 1 and minus 1. And so when I think in my head, this is going to have to be minus 1, and this is going to have to be plus 1, because then when you do the outside and the inside, you get a minus 1 here. So that's how it factors, which means what are my two solutions? 2x plus 1 equals 0, this is the zero product property, and x minus 1 equals 0, which means 2x equals negative 1, which means x equals negative 1/2, or x equals 1. Now these are my two potential answers, but whenever you do a log equation, you have to check for extraneous solutions. So let's see if they're right. Let's plug 1 back in up here, everywhere you see an x, and check if it's right. Log base 4 of 2 minus log base 4 of 1 equals log base 4 of 2. Is that true? And the main question is you want to ask is there any reason it wouldn't be true? You can't really plug this into your calculator very easily, but you can plug this over here into your calculator, right there. Or not into your calculator, but you can do that in your head. Log base 4 of 2 equals log base 4 of 2, and that's true. So that checks out. That solution is correct. Now let's try 1/2, negative 1/2. Negative 1/2. Well, you can see right away what's the problem.
Can't be negative.
Yeah, you can't put a negative in the argument or you can't take the logarithm of a negative number. And so this is an extraneous solution, meaning it's not a correct solution. So there's your answer, x equals 1.